It's an Australian company, marketing company, yeah, but we've actually been bought by an American company. So there's like two. I use technology from the US plus our company. I think we can hear them now. Awesome. Sure. Very good. So I'll give you.
It's audible.
It's audible? Wonderful.
Yeah, it's audible. You can start the presentation.
Cool. So the background, the motivation for this is that the online advertising industry has been relying on something called cookie. If you're not familiar with that, it's basically a small piece of data that your browser can save on behalf of a website, and publishers online use that to track your behavior as you go across the website, and then advertisers use that to track things like when you purchase a product or when you sign up, etc. So there's a long history. Many algorithms, many businesses have built up a technology that use these cookies. However, people are more and more these days concerned about privacy. So there's long plans to remove the cookie as a piece of technology in advertising. So in the advertising industry, everyone believes that the problem is once all that technology goes away, we have to replace it with something. We need some way of making advertising effective online. And in the advertising industry, most people believe it's going to be contextual targeting. So this is the old-fashioned way that people did advertising, which is if you've got a sport brand, sports sneakers, you probably want to show the ads on a sports website. If you have some cosmetics or you want to show beauty and fashion website. Yeah, simple idea of contextual targeting. The problem is that while there's good academic research in sort of psychology and consumer behavior that supports it, say that if people see ads in relevant contexts, they do form positive associations. A lot of recent research over the last few decades has shown it's more complicated than that. So, for example, sometimes the most effective ads are ones where they're slightly unexpected. So, for example, sometimes you might be looking at sport, maybe it's a sport page, like say rugby or cricket, and then there's an ad for a fancy watch or something. So it's like targeting maybe the same demographic, but it's unexpected. If all of the other ads are for sports sneakers, and then you see a watch, it kind of grabs your attention. So actually, online advertising is playing this hard game of you need the product to be in front of the right person in the right context, but it needs to grab their attention in order to be effective. So it's more complicated than the old-fashioned ideas of how advertising works. So that's the motivation. And so we want to use, because we're able to, we're focused on measuring consumer attention on the internet. Oh, yeah. Measuring attention so that we can understand how some of the subtleties of the way advertising works on the internet. So I'm going to talk about some of the tools, the machine learning-based tools we use. So the first thing is that we have a system for measuring attention time on ads. Basically, that our definition is how long people look at an ad for. And we do this by building machine learning models that are trained from eye tracking data. So the overall way that we do this is a kind of schematic representation. Move that little box out of the way. On the left-hand side is how we train and build the model. So at the top, we start with a panel of people who we pay their time. They install an application on their phone or their tablet or their computer, and then they allow us to track their eyes while they read media. So the idea is we want to collect real eye behavior of how people consume media and what they look at. So that gives us these two data sets, the eye tracking data and the log data, about how they scrolled, what they looked at, what time of day, etc. And all of that goes into our machine learning model. So what we want to be able to do is predict how much time people look at an ad, given what their behavior was at a particular time. Because most, when you look at a web page, they do have information about how you scroll and the time of day, etc., even if they're not tracking the time. So on the right-hand side, in the wild, then, anytime you're looking at a web page and an ad pops up, there's a stream of information sent back to the ad server that tells you what the page was, how fast you were scrolling, and then and where the ad was on the screen and for how long, and if you scroll off and scroll back on again. And we can use that to provide a good estimate of how long you looked at the ad. So the way we evaluate, we use standard machine learning techniques and standard evaluations, so root mean squared error, etc., for the model. But actually, the thing we care most about is an aggregated metric, because we don't care so much about the individual measurement, like this person looked exactly for 2 seconds. We care more about the average attention time on a given, because we're trying to affect, should we show more in sport, should we show more in beauty and fashion, or more in automotive? So it's average attention time for a given block of advertising we care about. So the way that we estimate our ability to estimate these averages is we use bootstrap sampling. So we have a holdout set of data that we test the model on, and then we use bootstrap sampling to repeatedly sample chunks of impressions from that data, calculate the predicted mean attention, and compare it to the actual mean attention. And that's our kind of core metric. So we can calculate mean absolute error here and see that we're kind of typically below 50 milliseconds in the estimates. And we can also calculate confidence bound. So we know roughly how far we are out. So our confidence bound, our 95% confidence bound tells us that we're about 100 milliseconds either side of true mean. Yeah, does that make sense for everyone? The second piece of technology we use is media context classification, because we want to know what type of content is the ad being shown on. So our parent company, Verity, has a machine learning driven API. So they're kind of core product that people use. And the basic way, the high level is, given a URL, this API then extracts the text content from the web page and the images, feeds them to a series of different classifiers that have been trained to predict different properties of the page, and then returns that as a JSON response. So in this research, all we care about is what's called the IAB V2. So the IAB is an industry body that provides sort of taxonomies and ontologies for how you classify web pages and apps and content on the internet. And we basically use the response tells us, we think this page, there's like an 89% probability that it's for. So those are the two pieces of technology. We want to categorize the content on the internet, and we want to measure attention. So that kind of leads in, once we have these technologies, we can now do large-scale data collections. We don't have to sort of humanly curate these things. So in this data set, which was collected in May this year, you can see we did it over 2 periods of time, because we want to compare how the patterns we find, how sort of continuous they are over time. In each of those 2-week periods, we had roughly 40 million impressions. And as you can see here, quite like 183 brands, 743 creatives. So the one brand might have multiple different ads with slightly different images and wording. So those, when we say creative, we mean the actual kind of visual ad and the variations they use. And as you can see here, they've been shown over large URLs. So it's as far as we're aware, it's the biggest data set of its kind ever collected. Unfortunately, we don't have a tool for doing the vertical categorization. So industry vertical is the idea that, maybe say the easy examples are Nike and Adidas are both the same kind of company. But there are more sort of confusing ones like, do you men's and women's shoes, the same kind of category, or should they be separate? So there's no IAB standard for that's globally used for vertical categorization. We in this work, we experimented with a couple of different categorization schemes, and we had to do them manually, the labeling manually. So there's a subset here that we've manually labeled for the brands in these vertical categories. So whenever I'm talking about industry verticals, it's this subset of data. The other thing to note is that as I go through you got a question? Yeah.
Very basic question.
Yeah.
Impressions. What is that impressions?
Impression, yeah. So good question. Every time, as soon as that's one person who got exposed to the ad. So in advertising technology, that's one impression. So you load up your web page, you look at a technology page, an ad comes up. That's counted as one impression. So that ad impression sends a packet of information back to the ad server, and then the advertisers get a report that says, today we had 100,000 impressions across these different websites at these different times. Does that make sense? Yeah, perfect. So we tested 3 different industry vertical categorizations. The IAB in Australia, they categorize advertising spend by year into a categorization scheme, but it's more focused on industries that tend to spend on the same kinds of advertising. So it's more of a macroeconomic analysis of advertising trends. We use the GICS categorization scheme, which comes from an international sort of finance and analysis body. So it's a global industry categorization scheme, very, very crude. And then we developed our own, which I'm showing here in the table, which is basically we're more focused on what the specific products were. So the first experiment we wanted to conduct here was understand to what extent should a given brand expect that their different creative advertising is going to perform well in the same media context over time. The methodology here is we take all of this data, we're going to group it by the brand of creative and media context, calculate the mean attention, so the mean attention of all the impressions within each of those groups. And then we want to calculate the percentage of a brand's creatives where each media context is either the top performer. So we want to know is there one media context like sports or automotive, which is always the top performer of that brand, or is there one media context which is always in the top group? And the ranking is always based on attention funds. The question is, can Nike put out an ad and always expect sport to be the top category that gets the most attention for them, or is there a lot of variability? And then we're going to plot that showing the number of creatives that brand has against that percentage of the time that's dominated by a certain category. And we also create a null model where we repeatedly sample creatives after randomly reallocating to brands. So that the kind of hypothesis here is if there is no real relationship between brands and media contexts, when we do this sort of random reallocation, the data should look the same. That's our null model. And we fit it to a simple exponential curve to get a sense of what the shape is. And this is what we saw. So on the x-axis there, you see as the number of creatives. So think of these as different advertising campaigns the brand runs is increasing. And then on the y-axis, you've got the category dominance. So the strongest category that the brand has, what percentage of the time is it the best performer or in the top three? So the pink is percentage of time that you've got one that's always the best performer. The dark grey is the percentage of time you've got one in the top three. So pretty clearly, it's decreasing as the number of ad creatives increases, but it appears to be asymptotic to some kind of level. So in the top three, times somewhere around 50%. This was quite a surprising result for us, actually. So we've done a previous version of the study, so 6 months prior, found a similar result, didn't believe it because no one in advertising really believes this. So did it on a bigger data set, found the same result. So it indicates that actually, even if you're a brand like Nike who produces a sport product, the environments in which your ads do well will vary a lot over time. You can't even rely on a single category to be in the top three more than 50% of the time, which is really, really surprising for us. And I think most people in the industry. And as you can see, the light grey shows the normal. Yeah. Yeah.
Does this reflect the idea that more natives to the dominance in the market users?
It's not so about dominance in the market. It's more about the reliance. So naively, people in advertising, I'll take an example, say Nike, they think we'll just run in sport media on sport websites and we're always going to do well there. What this is telling them is that, yes, like even if sport is your best category, you can only expect that to be in the top three performers 50% of the time, which means that the other 50% of the time, there's some other categories which are better than the thing that you think is going to be best. So it means that advertising has to be more sophisticated. They have to be searching for the right category. It could be market conditions. You could be right. Like this could be reflecting changes in competitors and market conditions. We don't know what the driver is. All we can say is that there's a lot of change and variation. Does that make sense? Yeah. Go ahead.
Does this reflect on the H2 consumer that means the more number of medicine the survey becomes?
Yeah. Like there's this advertising psychology term for that, but I can't remember what it is right now.
Hypnosis. Usually hypnosis.
Yeah.
Psychology.
Yeah.
What do you see? the more you stop seeing it.
Yeah. Yeah. It could be that as well too. Yeah, could easily be. So we repeat the same experiment, except rather than looking at brands, now we're looking at industry verticals. So say we had Nike and Adidas, we collapsed them into say sportswear as an industry vertical. Depending, we're using our custom vertical schema here, so that would be clothing and footwear as a schema. And then we want to plot this, and you get basically the same result. The data is a lot sparser because there's much fewer industry verticals than there are brands. And so obviously when we're fitting the line, it's not as smooth, it's not as clear response, but surprisingly, it seems like, at least in that top three notion, of the best performing top three, it's asymptoting to a level around about the same as what the brand level. So that was also surprising for us. We expected that, it would have been, for most categorizations, for the top one performer, it's worse than for the individual brand, which makes some sense. But for the top three, it's roughly the same. And again, better than null model. So again, we conclude that the industry vertical you belong to also indicates some kind of alignment between the kind of media context you're going to do well in, supporting some of the things that the advertising industry believes. So the next set of experiments, we want to understand how reliable this is over time. So the basic idea here is we want to group the data by industry vertical, creative media context in each of those two time periods. Remember when I showed you the data at the start, I showed you it was broken into two time periods. And then for each creative within the vertical and media context pair, we want to evaluate the performance of that creative compared to its overall average. So every ad campaign has an average attention. And then we want to know does this ad, is it higher than average in sports and lower than average in automotive and maybe average in say entertainment? Yeah. So where does it do better or lower compared to its overall average? And then we're going to show that as heat maps so we can understand it. So two heat maps, two ways of visualizing it. The one on the left is the mean percentage lift. So basically, like if the average is 1 second, and then in say sports, it's 1.2 seconds, you've got a sort of 20% lift. So that's just showing you where the green is, the dark green is higher lift, the pink is sort of negative, like sort of a reduction. And then on the right-hand side, it's a binary representation. So basically, of all the creatives, the different ads that are in that vertical, what percentage of them got lift versus not lift? So we don't care so much about the amount of lift, just was it positive or positive? Yeah. So and then we can sort of flick between them visually to get a sense of how this changes over time. It's imperfect because one of the periods didn't have all of the contextual categories. So I should have. There's improvements I would like to make to the way I visualize this in the future. But the first thing that's kind of striking about it is, first of all, it's a bit noisy, but there is some signal there. So I'll draw your attention to the top left-hand corner, top right-hand corner, you see a blob of blue. Things wrong. Blob of blue there, meaning these are combinations of industry verticals and contextual categories where they do quite poorly, and that you get the same pattern over time. So it remains sort of coolish. But then, we've done the same thing with different vertical categorizations. Again, we see the same thing. Noisy, but some signal there you can detect visually. So then we wanted to say, okay, how can we come up with algorithms for exploiting that signal to get a sense of how reliable it is? And that's the final set of experiments. We're basically saying, let's conduct a synthetic experiment. We've got all of this data. What we're going to do is pretend we'll go back to period 1, devise a targeting strategy, and then apply it to period 2 and see which way it works best. So it's kind of like testing different rules and so seeing how that happens. So basically, use the measurements of period 1 to understand the media context that the industry vertical does well in. Use that, applying some rule to select only the media inventory in period 2 and see if you get a lift in the amount of attention. That's the kind of general strategy. And so we tried different rule sets. So first two are based on attention lift, like the media context had to be greater than, like the first one is this has to be positive lift, greater than 0. The second one is greater than 20% lift. And the other two were based more, not about the percentage of lift, but the probability of getting them. So all of the creatives that from that vertical that showed in that context, what percentage of them got some lift. And so what you can see here is that, I mean, both rules, all four rule sets provide some value, but what we found is that even though visually it wasn't easy to tell the difference between our custom strategy and the IAB categorization scheme, the IAB scheme is giving us better performance. So for both, under both sets of rules, the best performer overall is that using the probability, depending on the criteria, so getting percentage lift of 63% lift in attention time, we're using that attention lift greater than 20%, but using the IAB categorization scheme. So this is kind of the first working draft of our attempt to understand how can we get a sense of what works in a given industry vertical and turn that into rules that can be used in an algorithm for optimizing attention for advertising. So the key findings is that we think measuring attention is useful as a method of understanding contextual alignments. We can see that because of the fact that we get, first of all, that the signal there better than the null model, and that we do see some patterns that conform to expectations. The contextual continuity for brands is to asymptote towards 50%. That was that first plot I showed you. So that using that the best performing category in the top three criteria, heading to about 50%. We also get continuity with the verticals, so not quite as strong as for the individual brands, but almost the same for the that top three criteria, and that you can use rules-based strategies to exploit that information for optimization. That's the key findings. Thank you for your time. Any questions? Sorry, any questions? Oh, did I have them? Yeah, this was just in case anyone asked about it. It's basically just indicating that, so each plot here is, these are 5 URLs. Each dot is an individual ad campaign. So what I'm showing you here is that, and then the large orange shows the mean attention on that URL. So one of the things we see is certain web pages just tend to get more attention for ads, but that high-level average hides the fact there's a high degree of variability. So sometimes, so even like on that 5th URL on the far right-hand side, you see that even though the mean attention on that site is really low, there are some ads that do really well on that website. So yeah, so this slide is just to illustrate that the distribution of attention times for ads, it's not normally distributed. These are highly skewed distributions that, and as you can see here, just a selection of 5 URLs, the distributions are probably not even the same. Yeah. Oh, right back here. This one? Yeah. So, MAE. Oh, my apologies. Yes, I should have said that. I said that when I was practicing this law. Banner and NREC are both different ad formats. So one of the things is the different format, and format means basically the size of the ad on the screen and maybe does it have some interactivity. So these are, banner and NREC are two standard international standards for internet advertising. So when you have your mobile phone, you get that little banner at the top. That's a standard banner. And when you scroll, and sometimes you'll see a square ad in the middle. That's an MREC, stands for medium rectangle. Yeah. Well, the medium rectangle, our error is higher, and that's partly because those ads get more attention. So these metrics, the problem is that the banner ads, in some sense, they're easier to predict because most people ignore them. So mostly they get zero attention, and it's easy to predict something that's zero. The NRECs get more attention, so the distribution of real attention times is like more drawn out, which means our errors tend to be naturally higher. Does that make sense? Thank you. Yeah.
you are collecting data sets like eyesight from and you are saying two types of data collection.
Yeah.
The first one is eyesight, and then second one is the log. Now, how you are collecting eyesight from?
Yeah, it's basically we have a number of applications. The first one we built was an iOS application that had inside it a convolutional neural network model that predicted where you're looking on the screen. So actually, there's a very good paper from MIT that was released about 8 years ago now. It was the first open source library with a data set that basically the data set was people's faces and then looking at a screen, and the target variables were X, Y coordinates on the screen. So you could train a model from the face to predict the X, Y coordinate where they were looking. And so we built our own data set for that as well, and then built that model and then embedded it in the iOS system. So basically, panelists come to us from various digital worker sites like ThinkWorker, Mechanical Turk, etc. They agree to be paid to install our application, read some media, and then we use the camera then to predict where they're looking at the screen. Does that make sense?
Yeah.
Thank you.
John, what I ask you is, is that inbuilt hardware in the device itself? Or
no, it's purely camera based. So there's a bit of a trade-off, right? So on that, just from the camera.
Yeah, you have that.
No, you have to install an app that does it. So it has to have the application has to ask your permission to turn the camera on, then the camera is on, access the camera, and then it connects for us. Yeah. So it's only when we run our panels. So it's a select group of people who allow us to do it, so we can collect the data.
Yeah.
Cool. Yeah. Yeah.
But you need to make some recommendations for
So yeah, this is work that's feeding into. We are preparing. So like everyone in the advertising industry, we're preparing for a chat removal of cookie. And we want to build new systems for advertising optimization. This is kind of like research work that's building to that, giving us ideas for how we're going to build those new algorithms to optimize attention. Great, thank you.
There any questions from online? I think there is no questions. Thank you once again. Thank you.
Cheers.
Yeah.